Let's have a quick look at the oil description for the third example. We will have the same main container, the CPU, and the same OS object. There is no change here. The same three tasks, A, B, and C, same priority levels. Here we need to highlight that task A is not preemptible and auto start configuration to be true. Task B is full preemptible and the auto start is false, and the auto start in task C again is false. Same priority levels. The only difference is the schedule parameter here. For task A is non-preemptible, and for task B is preemptible, full preemptible. Now let's have a quick look at the C code. We have a small difference here in the code. Again, we call the start operating system or start OS API in the main. In task A, instead of activating both of the other tasks, B and C, we increment the counter and activate task B. Once we activate task B, then another delay and explicit schedule point. Now in task B, we will increment the counter, call the simple delay, and activate task C from the context of task B. Then terminate, and same for task C, increment the counter, delay, and termination point. Now I will copy the oil description, paste it here in the os.oil that we will need it in order to generate the code, save the file, then trigger the generator. This is OSIGgen tool. Here the configuration files have been updated. So let's have the debugging session. Now in the debugger, compile the code, and now I am connecting my board into the PC. Then click Start Debug. Now we are in the main function. Let's have some breakpoints here. Let the software go. And now this is non-preemptible task, task A. And in non-preemptible scheduling, the activation of the task is not a scheduling point. So here, the execution of task A completes even if task B is ready and has more priority than task A. So the next breakpoint, we will hit the breakpoint here in line 41 instead of task B breakpoint. Now this is a explicitly scheduling point. After we call the schedule, we will have task B in the running state. Now task B is running and the counter of task B is incremented by 1, and this is a preemptible task, so the activation request is considered as a scheduling point because this is a preemptible task, and task C will be activated and running. Now we are in task C, then task C will be terminated and go into the suspended state. We will go back to the second task, task B. Now in task B, once it terminates itself, then we will go back to the first task, and this is the continuous loop it will be executed over and over again. Now again, the counters are almost the same value. Now this is a simple example about the mixed preemptible system. We have task A and B, preemptible and non-preemptible. Both of the scheduling methods were used here.